So if there is any point for which you require more clarification, you have queries, you can ask me. And if there is no query, then we can start with this session now. Okay, there is one message in chat box. Okay, no queries. Thank you. So let us start with last session of a day, which is dealing with feature selection, which is very important part. So feature selection in a theory, we everyone know. Feature selection means what? Select the most important features and leave the features which are less important, which will in turn increase the classification accuracy. So today only we will see how we can select the features. We'll not go into the detail that how it will increase the classification accuracy and all. That for that we have reserved one entire day for optimizing the models and all. Today we'll only see how we can select the features, what are the different ways of selecting the features and so on. So we will be using same dataset, that is Indian liver patient dataset, which we have already used. So we'll start with this import pandas as PD pandas you have already learned in previous session. Okay, Dhamajyoti ma'am is having a question. Feature selection is after extraction of features. No, feature selection means extract the required features, or feature selection is the process of extracting the required features or more important features or more prominent features so that accuracy of classifier can be increased. Okay, ma'am.
Means feature selection and extraction of feature are the same things.
First you select the features and then we extract the features.
Uh,
So this is what we can say in theory, but in practice, when you say feature selection, means you are talking about extracting the features also. That is something which is understood in practice. But in theory, yes, these are two different things.
yes, sir. ठीक. Okay, sir.
So we'll go with our file Indian liver patient dataset. And we can read that file using pandas as pd dot read underscore csv. Read underscore csv is a function using which we can read the data present in csv file. So this is something that we discussed in earlier session, that drive slash my drive, this is a path required where I have stored the file, and after that I can specify file name. So after reading this file, the data will be stored in object df. It's stored in the form data frame. So if I'll print it, print df, so it's in the form data frame. But now if we'll see, there is something missing. There is something also, I can say, different. This first row that they considered as a header. So the first row present in our file, it treated as a header, and it started considering data from second line onwards. That's why if you will observe here, see row indexes are from 0, and they goes up to 581, means there are 582 rows, but we know there are 583 rows. The problem is it considered first row as a header. By default, it considers first row as a header, but we don't want that. So what we are supposed to do? Next thing, specify header is equal to none. Means there is no header in our file. So now problem is solved. There are 583 rows, and since headers are not present, it used numbers as a header. So we are okay with that. Numbers as a header, we don't have any problem. So this is done. And now let us start working on features. So if I want to do working on features and all, then most important thing that we see, few things that Jay sir explained in previous session, that there should not be missing values. We should replace the missing values. Then we saw that, okay, if you want to work on a data, string data cannot, many machine learning algorithms cannot work on string data. And in our data set, there are string values. male and female, these are the values. So we should replace them. So how can we do that? Simple thing, df dot in the data frame replace. So replace, let's say, male by 0. But when we are replacing it, it does not pandas do not directly change the values in data frame. It replaces in a copy and returns that copy. It replaces in a copy and returns the replaced copy. So we should receive that. So we are changing it and receiving it in the same variable. So basically, we are not creating extra variable which saves the memory. So we are changing it and we are receiving the copying same object name. So extra memory space is not wasted. That's why in that way we are saving on the empty space. So we are replacing male by 0, and in similar manner we can replace uh, value female by 1. And now let us try to print this thing. Okay, cut. And now after replacing this thing, let's try to print this data frame. See, now you can observe here. Now there is no male or female value. It's replaced by 1 or 0. Then second thing, there might be some missing values at any moment of time. So we are supposed to replace those missing values. So now I'm not going to do anything fancy, upload, replace by, group by and all. Let's stick to very simple basic, that is df dot fill na. So fill na is a method. It's a fill na. Fill not available values by 0. So if there is any missing value, it will be replaced by 0. And again, we are storing it in df only. So these are few things which are required when we are going for feature selection process using sklearn library. Most of the algorithms which are available in sklearn library, they do not work with string data. And since they do not work well with string data, the alternative thing is replace the string values by some numbers. So here, so is it necessary that every time you should replace it by 0 or 1? No, it is not necessary. You can use any values, right? You can write 1 and minus 1. You can write 2 and 4. It's up to you. But it's always a good idea to write some small numbers. But now, if I check the type of this data frame, object, df object, the type is C. You can see over here. The type is pandas.core.frame.data frame. But machine learning algorithms or sklearn algorithms, they do not accept data frames. They want everything in NumPy array. They want NumPy array. So how can we do that? So there is a way provided by data pandas. It says df dot values. So if I use this attribute df dot values, it converts the data frame into NumPy array. It converts the data frame into NumPy array. So I'm calling it data. So now it will convert the data frame into NumPy array, and that array will be stored in the object data. That array will be stored in the object data. Let us print that NumPy object data. And now see here, this is in the form of NumPy array, 2D array. So this is the very first thing that we should do. First, open the CSV file using pandas. If there are any string values, replace those string values by some numbers. After that, if there are any missing values, replace those missing values. So once this thing is done, the next thing is we can convert the data frame into NumPy array with the help of values attribute. So it will simply return the NumPy array equivalence of a pandas data frame. And on now, since it is a NumPy array, we can perform various operations on that array without any problem. Any doubt till this point? I am copy pasting this code in a chat window for your reference. Please try this code. You have 2 minutes to try this code. It will not take more than that. And just check whether the code is working properly or not. And when it comes to path, over here, please write appropriate path. Rest all code is same. Meanwhile, if you have any doubt or query or difficulty in executing the code, please feel free to ask it. I hope you might have completed it. So, is there anyone who is having any problem or difficulty? No? Okay, good. Next thing, see, in this data set, there are two parts. First, 10 columns, that is index from location 0 to 9, that is first 10 columns. These columns forms a data for classification, whereas last column is a class target. So there are many different words by which researchers or people do refer it. It is called as a target, it is called as a label, or it is called as a class target, or it is called as a class label. We can call it anything. So, but most common words are label, target, and class. But sometimes you call it class label, means you are combining the words class label, class target, target class. So it doesn't matter. So now we are supposed to segregate these two things from this. So now we want two things. We want this data and we want this class label. So this data part is normally referred as X and this label part is normally referred as Y. So why it's just a common convention. So I'll be following that convention. So this part, data part is called as X and this part is called as Y. So data part are column numbers from 0 to 9 and this is the part last column number. So how we can easily extract it in one line? Yes, we can easily extract it in one line. I can write X is equal to data. It's our numpy array colon. I want all rows. So I'll write colon over here, comma. Before comma, we specify row numbers. If I want all the rows, I'll write colon. But what about columns? Do I want all columns? No, I don't want all columns. So I'll write 0 colon. How many columns I want? I want all the columns except last column. I want all the columns except last column. So how can I go for it? So first, let's see what is the shape of a data. So if I'll print data dot shape, so it is returning 583 comma 11. It says there are 11 columns and 583 rows. So data dot shape returns two values. Zeroth value is rows, number of rows, and first value is number of columns. So I'm going to use this approach only, this thing only. So X is equal to data of colon means all rows, comma, column number 0 up to which column 0 column. So I'll go with data dot shape, which returns two values, row number, column number. I want number of columns. So we'll write of one. So when we write data dot shapes of one, it returns number of columns. But we don't want last column. I don't want last column. So I'll write -1. I'll write -1. So what this line says, this line suggests in X array or it create a array X from data array in which I want all rows because it's there, but columns starting from column number 0, simply skip last column. That's it. And column Y which contains only labels. So again data. I want all rows, but I only want last column. But I only want last column. So here only I'll write data dot shape of 1 minus 1. I don't want, so now here I want only last column. So here why I'm writing minus 1, because Python is a zero based language like C or Java or C++. So here if a length of array is 5, we write it is A of 4. A of 4 is the last element. Why? Because it's a zero based language. Similarly, Python is zero based language. That's why I'm using minus 1. So now if I'll print the shape of X and Y, X dot shape, comma, Y dot shape. So you will see shape of X, there are 10 columns, and in Y it is 583 rows, comma nothing. Comma nothing means there is only one column. Comma nothing means what? There is only one column. So this is how we can segregate X part and Y part, that is data and label from each other. I'm copying this data in our chat window for your reference. So take a minute to try and run this code so that we can move forward. Today's part, this session is very important session, though it's the last session of a day, but it's very important session because without feature engineering, getting a better accuracy is almost impossible. Featuring engineering is a step which you cannot eliminate. Okay. Then next step is dividing the data into two parts, train part and test part. So for that, there is a library in sklearn from sklearn dot model selection. We can import train test plate. So why train test plate? So train test plate is very important. Why it is important? Just take an example. Let's say you are a maths teacher and you taught students, let's say 20 sums on particular topic in classroom, and in exam you are asking sums from that sums only. You ask three sums in exam which you have already covered in lecture session. So what about student? So will you be able to properly identify the student's understanding? No, because if a student has completely understood, he will solve the sums perfectly, or the student has only mug up those examples and simply replicated the thing. That is also possible. Students can mug up anything. And why this thing happened? Because training and testing was same. You use same number, you taught the sums and you asked sums from that set only. Then what is the better idea? You teach them 20 sums and ask another three sums which you have not covered in the session, but on same concept, on same topic. Now you can properly check the student's understanding. If student's understanding is proper, he can solve the sum. If student has only mug up the sum which you have taught, student will not be able to answer those sums properly. So means what? It completely depends on how you are training, taking the test, and how you are training the student. Means what? Your training and testing data should be different. That's why we should do train test split. So here what happens, when we are selecting the features, we are supposed to select the features based on training data, not on testing data. That is most important thing. Testing data we are supposed to leave aside. Select the features only on train data. So so this is a train test model. So now what we are supposed to do to this train test split method, we are supposed to pass two things, that is first X part and Y part. Now we say, okay, this is a training part, these are the class levels. And next thing we are supposed to specify the split size. How much data you want in the test split? How much data you want in a test split? So we can say that test underscore size is equal to 0.3. It means what? 0.3 means 30%, 0.4 means 40%. So here when we say 0.3, it means 30%. So divided it into two parts, 70% and 30%. 70% data, training data, 30% data, testing data, because here we have specified test size. So the return value we are supposed to receive in appropriate objects, and those are x underscore train, comma, x underscore test. So it first divide this x into two parts that we will receive in train, x underscore test, and then y part, y underscore train, comma, y underscore test. So now we will have 70% records in x train and y train part, and 30% records in x test and y test parts. So now if we'll print the shapes of these attributes, x underscore train, comma, y underscore train, comma, x underscore test, comma, y underscore test. So, sorry, I should have print the shape instead of printing the entire object. Sorry for this. Shape dot shape and dot shape. Now we can see. Now 408 records are in X test part, X train part. Label 408. So and in testing part there are 175 records. So 408 records can be used to train the classifier, and 175 records can be used to test the classifier. Now when we will be going for feature selection, we'll be using only train part to select the features. We'll be using only train part to select the features. Testing part is not used for feature selection. Only this part. Okay. So now I'll copy paste this part of code for your reference. So dividing the data into two parts, train part and test part. So please take a minute and run this code. So everything else from here depends on this X train and X test only, nothing else. And if you have any doubt, please feel free to ask. Okay, I hope it's done properly without any error. So now let's go for first method of feature selection, that is a variance based feature selection. So for that the library is from sklearn dot feature underscore selection will import variance threshold. So variance threshold means what? It looks for the variation. Variance means variation in a column. Let's say what do you mean by variation? Variation means how many different values are there in a column. Take an example. Let's say in one column values are 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. And there is another column in which values are 4, 5, 6, 7, 1, 7, 4, 5, 3, 1. So let's say this is our column 1. So in this column there are only three values, 1, 2, 3. Whereas in this column number of different values are more. So we can say variation in this column is higher as compared to this column. Means what? Variance of this column is higher as compared to variance of previous column or first column. So this is called as variance. So many people do think that if a variance of a particular column is higher, then that column is more suitable for classification as compared to the column whose variance is less. This is a very old, what we can say, technique, but yeah, still it works. So what they are suggesting here is select the columns whose variance is above particular threshold. So that is variance threshold based feature selection. So how can we do that? Now here what we can say is we'll create a object, let's say selection object, which is object of variance threshold class, variance threshold class, and here we are setting the threshold to be zero point 0.2. So now what we are telling that only those columns, select only those columns whose variance value is greater than or equal to zero point 0.2. Select only those columns whose variance value is greater than or equal to zero point 0.2. So once it is done, decided, let us fit select dot fit. So fit is a method which we are calling on a data x underscore train. So what it will do when we'll call this method fit on a extend extend array. So when we are calling this method fit on extend data, it will calculate the variance of every column. It will calculate the variance of every column. It is only calculating the variance, doing nothing. It is only calculating the variance. It is not doing anything else. After that, what we are doing, we are calling the method select dot transform. Select dot transform, to which we are again passing x dot train method. Sorry, exact train object, and we are receiving the returned value in x underscore train underscore trans object. So what it will do when we'll call this fit method, it will only identify those columns which are having variance more than zero point 0.2. And when we'll call this transform method, it will keep only those attributes and will delete remaining attributes. It will keep only those attributes whose variance is more than zero point 0.2, and it will delete remaining attributes. So now x underscore train underscore trans, or let's say transformed, this object contains only those attributes. This object will contain only those attributes whose variance is more than zero point 0.2. Whose variance is more than zero point 0.2. So let us print this thing. So first we will print the object, let's say x underscore train underscore trans, and now print the shape of that thing, x underscore train underscore trans dot shape. Did something wrong? I forgot. Okay, I did a spelling mistake. It is transform, and one more spelling mistake. Okay, now you can see here what it has given. Shape is 408 rows in training data, but number of columns are now 8. Actually, in actual x underscore train, we have 10 columns, but now it is showing only 8 columns. Why? Because according to this thing, there are only 8 columns whose variance is more than zero point 0.2. Let's check, go for zero point 0.4 and run it. It's again 8 columns. Let's go for higher variance 0.7. Now there are 7 columns. If I'll get 0.8, 7 columns. We can go higher 0.9 and so on. Means most of the attributes are having very high variance. Most of the attributes are having very high variance. That is a good thing. So this is important part. Here, this based feature selection method is having a major problem. And that problem is we do not have control over number of attributes to select. We do not have control over number of attributes to select. Okay, now there is a question that how to select the threshold. So actually, normally people do select a threshold 0.7 or higher. They says higher the threshold, it's better. But let's say you have selected a threshold 0.8, but and you don't have sufficient number of features. Then what you can do? You will decrease the threshold. So number of attributes, if you want more, you can keep a lower threshold. And if you want less number of attributes, you can go for a higher threshold. So now we apply transformed on trained data. But when we are training a machine learning model, number of attributes in training data and testing data must be same. Number of attributes in training data and testing data must be same. So we must apply this transformation on training as well as testing data. So we'll apply this transform on train as well as test. So we have x underscore test underscore transform and x underscore train underscore transform. And now let us print the shape of transform data also, transform test data. Oh, did something mistake. Okay, here I should write x underscore test. So 175 rows in test data and number of columns are now 7. So when we do feature selection, after feature selection, we extract only those features. And those features must be extracted from training data as well as testing data. Because in machine learning, number of features in training data as well as testing data must be same. But feature selection process is applied only on training part. At that time, we exclude test part from it. So this is most important thing. We must split the data before selecting the features. If you will split the data after selecting the features, that will not work properly. Okay, there is one more question from Saima madam. Sir, how attributes will be same in train and test? It will be same in train and test because see, we are fitting the model first. So this cell is object, selectation is object. We are fitting that object using training data. And then we are using that object for transformation on training data as well as testing data. Means we are using same object for transformation on training data as well as testing data. Na? And this object is trained for same features. That's why. If you will use different object for training data and testing data transformation, then number of features will be different. But if we are using same object for transforming training as well as testing data, number of features will remain same. I hope I answered your query, ma'am. Okay, see, the target is not present. That is okay because variance based selection only works on what? Attributes. It does not take target into consideration. That's why target is missing. But when we call it here select.fit on training data, it calculates the column numbers. It calculates the column numbers or it identifies the column numbers which are having higher variance. And when you apply transformation, it extract only those columns. So it will extract X number of columns from train and same X number of columns from test. That's why without label also it works fine. Okay. So I'm copy pasting this code in a chat window for your reference. So you can try it now. It will hardly take a minute to run the code, not more than that. Meanwhile, I'll answer the question. Okay. Josna ma'am has a question from 1000 rows, 700 used for train and 300 for test. But columns will be same.
That is
Yeah.
not a question, sir. That is just answer for
Uh,
previous ma'am's query.
okay, ma'am. Thank you, ma'am. Okay, there is one question from Madhvi ma'am. Sir, so suppose our train data has 7 features. Then from testing data, we should remove other attributes except those 7 features explicitly. Yes, ma'am. Number of features, not only number of features, features must remain same. Okay. So I hope you must have tried this code. It will not take much time. So let's go to next part. So this is variance based, but variance based is the old method. Nowadays, what people are doing, they are selecting the features. Nowadays means for many years, they are selecting the features by considering relation between attribute and a label. What they are saying, why only consider variance? We should consider the relation between attributes and the label. Those attributes which are having more relation with label, higher relation with label, those should be selected, and attributes which are having less relation with the label should be removed. Should be removed. So for that there are many methods. So we'll go with two methods only in this session. Let's say from sklearn dot model selection, we are importing select k base. Select k, select k based. So did something wrong? Cannot import from sklearn dot model underscore selection import select paste. Okay, missing package. You can manually install dependencies either using. How can it happen? Okay, just give me a second. I already tried this course earlier, so there should not be any problem, I guess. Oh, I don't know. There might be some typing mistake from my side. Okay, so we are importing this select k based. So this basically this k based, it removes the depend problem of a variance based selection, where we don't have control on number of attributes to select. Here we can specify k number of attributes, that I want 3 attributes, I want 4 attributes, or best 3 attributes, best 4 attributes. And then from sklearn dot, oh, earlier I was writing model selection, I don't know, feature underscore selection, uh, will import chi-square. So chi-square, every we must know, or everyone knows this from maths. So what chi-square does, it calculates the dependency, it calculates the compatibility between two attributes. So here chi-square is used to calculate the compatibility, or what can dependency between our data attribute and a class label. And based on that, it selects the attributes which are most compatible or which are most dependent on each other. So let's create the object select of sklearn, select k based, select k based, to which we will pass I I want to use chi-square method, and how many features I want to select. Let's say I want to select 4 best features, and rest of the code is same. I can directly copy paste the code to save on time. Copy and paste. The only difference is here along with X train, I'm supposed to pass what X test also, Y train also, no? So here we are passing data along with class label. So now chi-square will, what chi-square will do? It will take one attribute at a time from train data, and it will check its compatibility with class label, and it will select k number of attributes, best k number of attributes from the data. And after that, similar things, we can apply transformation on train data to get the transform features, that is a k number of features, and same transformation we are supposed to apply it on a test data. So after running, we can see. So we get 4 best features. So if I want 6 best features, simply replace k by 6, and I have 6 best features. And now I'm only copying this code in our chat window. If you want, you can try this code while you are listening to the session, but I'll simply advise that, okay, first pay attention in a session because I hardly have 15 minutes remaining with me. So chi-square is one approach. So is there any approach similar to chi-square? Yes. There is an approach called mutual information. For that, instead of chi-square, we'll import f underscore class if. So it uses something called as ANOVA, analysis of variance. It is also something which we must have studied during our engineering, analysis of variance. So it calculates the f value using analysis of variance, and that f value is used to select the k based features. That f value is used to select the k based features. I'll not go into detail how to calculate that values and all. It will take a very long time period. So basically it calculates the f value using analysis of variance, and then it selects k number of best features. And obviously we can specify the value of k, whatever we want, like this. Uh, I'm copy pasting same code, this modified code in chat window for reference. Okay, there are questions. Uh, can we use chi-square for numeric columns? Chi-square is used only on numeric columns because it is having a mathematical formula, some subtraction, then division, then square, and something like that. So it must be numerical column only. And second question, sir, attributes and features are different. See, the main Damojyoti ma'am, attributes and features are alternative words. Either we can call it attribute or we can call it a feature. Both words are same, alternative names.
Okay, sir.
If it is categorical, you should convert those things into numbers. But categorical values, it's like they have their own inbuilt meaning also, interpretation also. If you want, you can apply chi-square test on it, but it will not work properly. In that case, you should go for mutual information or information gain, something like that. The chi-square and all, it will not work properly. So category means, so they are specifying the categories now. So let's say low, medium, high. So if such are the categories where their mean low means 0, medium means 1, and high means 2. If you are using that way, it is okay. But let's say your categories are book, PDF, printer, and all. Now can I apply? No, I cannot apply. So depending on what kind of categories you are dealing with, you might be able to apply. Saima madam, I hope I answered your query. Okay. Then the next, okay, I think it is used for categorical columns. Ma'am, can you unmute yourself and ask it in more detail so that I'll be able to answer properly?
Hello, am I audible?
Yes, ma'am.
Yeah, sir. Sir, I think for finding out the feature importance, I think chi-square test is used for on categorical columns. I think so. That's why I asked you that, like, can we use it for numeric columns or not?
No, numeric columns, it works. It is basically for numerical columns.
Uh,
This is something which I read in statistics books. So there might be some other way of research also. Categorical values, yes, you can use, but when you go for categorical values, as I told you, if it is low, medium, high, or it's like there are some categories which have some inter proper meaning, and you can rank it properly. Let's say 0, 1, 2, 3, 4, low, medium, high, very high. It will work. It will work perfectly in that case.
oh,
Every
okay.
kind of every type of categorical data, it will not work, but on some kind of categorical data it will definitely work. For example, as I told you, um, height, small, medium, high, very high, and you can say small is 0, medium is 1, high is 2, very high is 3, or in reverse order it will work.
Okay, sir.
Okay, thank you, ma'am. So next and most important thing is we can select the features according to the classifier, according to the classifier. This is something which is not much preferred by researchers, but since it is there, you should know it. From sklearn.tree, I'm importing decision tree. So what people says, if you are selecting the features for a decision tree, then features should be according to the decision tree. The features which are good for decision tree might not be good for support vector machine. The features which are good for support vector machine might not be good for decision tree. So that way they says, okay, so you select the features according to the classifier. So from sklearn dot feature, not extraction, feature selection, we are importing recursive feature elimination, RFE. Recursive feature elimination means what? You start with all the features and then eliminate one feature at a time, and then eliminate one feature at a time. So here we want a decision tree. So I'll create a decision object of decision tree classifier. Let's say DTC is equal to decision tree classifier. I'm creating object of decision tree classifier, and then I'm creating the object of recursive feature elimination class RFE, to which I am passing that my estimator, that is the machine learning model that I will be using, is a decision tree, and this is the object DTC. Then how many features to select? So I want to select n underscore features to select, features to select. Let's say I want to select 5 features, and step is equal to 1 means what? In every step, eliminate one feature. So we have 10 features now. So it will first eliminate one, then second, then one, then one. So how many steps will it will take 5 steps, because we have 10 features and we want only 5 features. So it will take 5 steps to get those features. And after that, it's same what we are supposed to do. We will fit it, select, oh, sorry. We'll fit this object using train and test data. And once it is done, then we can go for transformation and everything. So we get 5. But there is one important thing that this gives us. It gives us feature ranking. It gives us feature ranking. Now let's say if I'll print this thing, print SEL dot ranking underscore. So I want 5 features now. So it is, see, there will be 5 ones. 1, 2, 3, 4, and 5. These 5 ones simply indicates these are 5 most important features. And after that, if you want to go for 6 feature, then this feature, then this feature, then 4, and then 5 and 6. So that way. So basically, most important features are this: 1, 1, 1, 1, 1. So it gives us a feature ranking also. So this is a recursive feature elimination. So I'm pasting this code in a chat window. Recursive feature elimination. This is something called as aggressive strategy of identifying the features, but it works. So you train your model using entire data, select some features and use only those features. So here we are selecting features specifically for decision tree classifier. This is not a general mechanism. This is a specific mechanism. So if you are selecting it for decision tree classifier, these are the best features for decision tree classifier. You cannot use it for other classifiers. If you may use, but the accuracy is not guaranteed. But the accuracy is not guaranteed. So I have copy pasted the code in the chat section. So if you want, you can try this code. And if you have any query, then please feel free to ask the query. So this was for feature selection. Feature selection is most important thing. If you want a best accuracy features, there is no alternative to feature selection. Okay, so if you have any query, please feel free to ask. Otherwise, we'll stop here today.